is about logs. And if I recall, lesson 3.4 is about logs. So our next 2 days are going to be logs. Unfortunately, we won't get to lesson 3.5 or 3.6 this week. But my plan is 3.3 today, 3.4 tomorrow, Tuesday, review worksheet on Wednesday. You guys have class on Thursday, so going over questions and review and quiz over these 4 sections. Sorry, the word final started to come out of my mouth, which is not, no. Mix that.
4 sections and that's it?
Yes, that's all we have time for. That is my plan, to not make it hard. Okay. Yes, because we'll have like an 80-minute period or something. And I plan to make the quiz short, not, my busting the seams to get through them, My plan is to make it a shorter than normal quiz. So we'll see what happens. Okay. Logarithms. Yes.
Does the thing say a log and then B x equals y?
Where are you looking at?
Logarithms is the first equation. Subscript B.
Yes, that is a subscript B. Okay, so logarithms. We went over these a little bit back in Algebra 2, I believe.
Yes.
I think. Okay, so they're not brand new. Logarithms, our common form of logarithms is log, that's a subscript B, of x equals y. So when you see something in log form, this is what we talk about, log of base B of x equals y. Remember the phrase left, right, middle?
Yeah.
Okay, left, right, middle is what we use to go back and forth. It will take us out of logarithm form into an exponential form. And that's good because exponential forms we have more that we can do with, more ways to solve, more ways to work with them. And so left, right, middle is the base is the left item. So the left raised to the right equals the middle. So B to the y equals the x. Come up with whatever ways work for you to remember that. I tend to think my base B here stays my base B here. X and y switch. You can think that way. And again, left, right, middle. So when you hear me say left, right, middle, when you see me write LRM on a paper, no, that's what I'm talking about. Again, a whole bunch of different stuff we're doing with logs, some without calculators, some with calculators. My goal is to get most of these notes. I'm not doing example 8 on the back. We're going to kind of skip over graphs because time-wise, I know I'd be pushing it. So, example 1, evaluate the following logs. The following logarithms, meaning I want to know what log base 2 of 8 equals. This is not a calculator problem. This is a set it up and show me your work problem. Okay? My suggestion to give you a hint to get started is to say, okay, log base 2 of 8 equals y. Thoughts on what I can do to find y?
Well,
There's 3 words, left, right, middle. Okay, take it out of log form, put it in exponent form. So left to the right equals the middle. So 2 to the y equals the 8. You did this last year.
I remember this.
Okay.
because that was the left right middle right there.
That was left, right, middle, yep. How do I solve 2 to the y equals 8? He says it's 3. That doesn't tell me how I solve it.
You plug in numbers.
I don't want to just plug in numbers.
You take the y root of 8 equals 2.
Okay, so, yeah, what I look at is, this is a base of 2. Can 8 be rewritten with a base of 2? In other words, is 8 equal to 2 to some power? Yeah, it's 2 to the third. So 2 to the y equals 2 to the third. If the bases are the same, then...
Oh, you cancel the things and put y. Yeah.
Yeah. If the bases are the same, then the powers have to be the same. I got equal bases of 2, so I dropped the 2's off, and I know y equals 3.
So they have to like equal.
Yeah, your goal, if you can, is to get your bases equal.
And if they don't,
I don't think we're talking about that today.
okay.
I remember this.
Okay, B. Log base 3 of square root of 3. And yes, you're always going to see me, at least for these, write equals y. How do I rewrite this?
3 to the y equals square root of 3.
Okay. 3 to the y equals square root of 3. That was left, right, middle. What do you know about the square root of 3? Okay, square roots. Remember we talked about this last week in this class, I think. That when there's a radical, remember this is a square root, so it's a denominator of 2. There's no power on 3, so we assume an invisible power of 1. So 3 to the 1/2. So y equals 1/2. Okay, so we've got a basic one thrown in there. We've got a square root one thrown in here. Now we've got to throw our fraction in. Log base 5 of 1 over 25. So I'm going to start by saying 5 to the y equals 1 over 25. What are your thoughts about 1 over 25? No, wait. Let me rephrase that question. What about 25? 5 squared? Is that one? So think of this instead, if you will, as 1 over 5 squared. 1 over 25 is 1 over 5 squared. So how do I get these both to have base 5? How do we get that 5 with an exponent out of the denominator? Negative exponent. And so 5 to the y, if it's 1 over 5 squared, bring it up, you make it 5 to the negative 2. 5 to the y equals 5 to the negative 2, so y is,
So we made that -2.
because to move something from denominator to numerator, numerator to denominator, you make it a negative exponent. Just exponent rules there. To get something out of the denominator, it has to become a negative exponent. Log base 4 of 1. I'm going to say equals y. What's left, right, middle, tell me? 4 to the y equals 1. Okay, guys, this is a good one to just know. How can I rewrite 1 with a base of 4? Anything raised to what power is always 1? Yeah, so you can think of 1 as being 4 to the 0, because anything raised to 0 is 1. And so that tells me y is 0. Because go back to the original equation I wrote. 4 to the 0 equals 1. And that's a good flat out rule to just know. Log of 1, any base is always 0. Always. And this next one's a good one to just know, but we've got to figure it out first. Log base 7 of 7. Okay, so I'm going to say log base 7, 7 equals y. Left, right, middle. 7 to the y equals 7. The invisible power? 1. So 7 to the y equals 7 to the first, and so y is 1. What's the rule there to know? When your base and the inside of your log are the same, that log equals 1. So log base 8 of 8 would be 1. Log base 1,000 of 1,000 would be 1. Okay? Now, those last two we just did play into this next line of properties of logarithms. Notice that very first property. We talked about this on part D. Log base b of 1 is 0, always. Number 2, log base b of b, so when the b's match, the log is 1, always. Now, property 3 could have helped on technically a, b, and c, but when you have log base b of b to some power, that log is equal to that power. Okay, and we could have done that, for example, on a here. We could have said log base 2 of, instead of 8, 2 to the 3rd. Well, then my 2's would match, and so my answer would be the power of 3. And then we haven't used this one, but if you have the situation of a log exponent, so base b raised to log base b of y, if those b's match, it's equal to the inside of the log, so y. Okay, those are good rules to know. Now, the first row, I did left, right, middle on every single one of them. This next row, not going to lie, you can do left, right, middle, but you don't need to do left, right, middle if you know your properties of logarithms. Okay? So let's look at example A. Log base 3 of 27. Up above, I would have said equals y and left, right, middle. Instead, what do you know about 27? It can be rewritten as what to what power? 3 to the 3rd. 3 times 3 is 9. Times 3 is 27, right? So, the idea here, log base 3 of 3 to the 3rd. Well, what does property number 3 up above say my answer is? 3. And technically, let me clarify, which 3? The exponent 3, right? So that right there, because that was 3, says my answer is 3. It's not, these 3's just have to match each other. They don't have to match the power. And I'll clarify that on the next example. Example 2b, log base 2 of square root of 2. What do you know about square root of 2?
2 to the 1st.
How do we write a square root power? 1/2. Because remember, radicals always translate into exponent powers. So what is log base 2 of 2 to the 1/2 equal to? What? 1/2? Because these 2's match, again, this is property 3. As long as the base and the inside base match, it's equal to the exponent. So these 2's match, so it's equal to 1/2. And again, not that you couldn't set up an equation, do left, right, middle. Okay, C, log base 25 of 25. Well, don't even have to do that much. What does property 2 tell us? If my base and my inside are the same, 25s are the same, so what's this equal to? 1. Now, if it helps, you can also think of this as property 3 because we could always put a power of 1 up here on the 25, couldn't we? And then it's the same property I used in A and B. Okay, D. That is 6 raised to the log base 6, I assume, of 7. What is this one equal to? 7. As long as those 6's match, it's equal to 7. And E. Log base 8 of 1. Of course. Log base 8 of 1 is 0. Because log any base of 1 is always 0. Stick those in your head, okay? They randomly come up in math classes. They're good to know. Okay. Continuing along, unless you have questions. What? The properties? Yeah, I wouldn't provide those. Just because the properties, it's one of those things. Once you use those, the more you use the properties, they become familiar with you. But no, I don't think. I guess I don't have the review worksheet or quiz made for this week. But my thought would be no, I would not provide. Okay. All the logs we just talked about provided a base, yes? If a base is not provided, what do we know? It's base 10, right? It is also called the common log. Okay? So if there's no base provided, it's base 10, common log. We're going to go into example 3. Notice it says evaluate without a calculator. Why does it say evaluate without a calculator? What property does the calculator automatically do? Base 10, yes? Calculator automatically does base 10. So yes, technically you can plug this in on the calculator. But the point is, use the properties we just talked about. Okay? Log of 100. What do you know about 100 that's important here? $100 is 10 squared, and since this is base 10, that makes a difference, right? Because look at how I just wrote this. I wrote in the base 10 for the visual purposes. Log base 10 of 10 squared. My 10s match, so this is what? 2. And then we're still getting those, working with the powers there. Yes, your calculator would say 2 as well. And if I put something like this on a quiz, I wouldn't necessarily, but I could, and I say no calculators, that means you would have to show me that step right there to prove that you understand why it's 2. That's what, this says no calculators, show work. Writing that step is showing your work. Okay? Example B. Log of 10 to the 5th root. Log base 10 of 10 to the what? 1/5, because instead of a square root where we do 1 over 2, it's a 5th root, so we do 1 over 5. And so since my 10s match, 1 over 5. See, part of today, the point is, I just got to get your brains thinking in the right way with all the powers and everything. Again, because it's the properties. So when we have, for instance, that, the cube root of x to the 5th. I'm just randomly making this up. Don't look at the paper. But the idea here is that to take this out of radical form into a power, the 3 goes in the denominator, the power goes in the numerator. You just got to know that at this point. That was an Algebra 2 lesson.
Yeah.
Okay, so that's why. So on these, when I say 1/5, that's because there's a power of 1, no other power other than 1.
Yeah, like the invisible one.
Yeah. Okay. Log of 1 over 1,000. What would be important to know about 1,000? A 1 with 3 zeros is 10 to the 3rd. Okay, so if we think of this for a moment as 1 over 10 to the 3rd, that does not look right because that went from a unreadable 3 to a 103. Try that again. Yeah. Now we'll go back to the squishy 3. What do you know about 1 over 10 to the 3rd? To get that 10 to the 3rd out of the denominator, make it a negative 3 and bring it up. So this is going to be the log base 10 of 10 to the negative 3. What's that mean this equals? Negative 3. My 10s match, so negative 3. 10 to the power of log 6. What do you need to remember to do this problem? Okay, it's similar to D from the above group. Property number 4 from those properties up there. That log 6, what base is log 6? It's a 10. So, base 10, they match. What does this equal? 6. And log of 1, any base? 0. Okay. You do actually get to get your calculators out on this one. Okay. Evaluate the following on your calculator, which means, is there work to show? No. You just find the log button on your calculator, which is on the left-hand column. And how do I do log of 34.5? Log 34.5. 1.5378199095. I have 3 decimal places written down in my notes. So, 3 decimal places. 1.538 is the approximation. It is an approximation. It's rounded. Okay, notice that is log of a number bigger than 1, and it is a number, a positive number, yes? Okay, have you done log of 0.43? Negative. Negative what? 36, did you say 65 something? So that's going to be 0.367. Okay. So notice, a log of a number less than 1, or between 0 and 1, is negative, and it's a decimal. And it's a number less than 1. Okay? I guess I never did that one on here, did I? Okay. What about log of negative 3? Okay. Error. That's the most important thing. It says non-real answers. Notice it says in real mode, all calculations must result in a real number. Okay. So it's always helpful. I know some of you guys just say error and then you immediately hit clear and you don't even look at it. It actually will tell you some helpful information sometimes. Sometimes I know you're like, it still didn't, I read the error message and it still didn't help me. But sometimes it does help. So, log of negative 3. What are we trying to get at here? Can you take the log of a negative number? No. I'm going to use the terminology that the log of negative 3 is undefined, because we can't take the log of negative numbers. Honestly, I'm going to assume yes based on its answer. Honestly, I'm not sure that I've ever worked with that. So, okay, now, real quick. I want to talk about the graph here. Do you guys remember? We're talking about logs here. Okay, so we had an exponential graph. Exponential graph we talked about last week went like this, yes? Okay, the log graph is the inverse here, and the log graph goes like this. And where it goes through right there, it goes through at x equals 1. And notice, can you tell by looking at the graph? What is that y-axis acting as? That y-axis is an asymptote. Which? So will you ever be able to take the log of any negative number? No. Notice, the log of a number that is less than 1 will always be down here, so it will be negative and small. The log of a number greater than 1 should be positive and bigger than 1. So that graph can tell me a lot there. Okay, you got it? Moving on to example 5 then. Solving, I think that's supposed to say simple. Solving simple logarithmic equations by changing to exponential form. We've already done some of this to an extent up in the top section. Some of it will be even easier though. So log of x equals 3. How do I solve log of x equals 3? What? Okay. And if I do what I did at the top, what's that phrase? What? Lerm? Okay, I'll take lerm. Okay. I'm going to write down L-R-M. Shively's going to pronounce it lerm. I get it. Just took me a moment to hear you through the mask. That's my excuse, at least, of why I didn't understand you. What do you have to know about log of 10? It is base what? What do we have to know about log of x? It is base what? Base 10. I don't think half of you guys even caught I said that wrong. Okay, so left, right, middle says 10 to the third equals x. How do I solve this? You do 10 to the third. There's no solving.
Basic algebra.
What is 10 to the third?
Like 10,000. 1,000.
A 1 with 3 zeros, so 1,000. Okay? Let's do B. Another easy one. This time they actually gave us the base, the only difference really. Log base 2 of x equals 5. What do we do? 2 to the fifth equals x. Left, right, middle. So what is x? 32. That's a good number to just know if you don't know it. 2 to the fifth. Okay. Good one to know. Okay, what about C?
Base of base, so that would have to be 3. 0.19.
No.
To x.
X is in a different location here. 3 to the x equals 1/9.
Negative.
What?
Negative.
Negative something? What do you know about 9? 9 is 3 to the second. So you can think of this as 1 over 3 seconds, 3 to the second. And since it's 3 to the seconds in the denominator, to get out the denominator, I make it negative. So 3 to the x equals 3 to the negative 2. Like up above, x is negative 2. Okay, one more on this row. Log base x of 64 equals 3.
So,
X to the third equals 64. How do you solve an equation that says x to the third equals 64? Okay. So one option is to do the cube root. Since it's x to the third, you can do the cube root. Or, like earlier, we could get the, kind of like earlier where we were trying to get the bases the same, we could get the powers the same. 64 can be rewritten as what to the third power? 4. So you could also think x to the third equals 4 to the third. Well now, if the powers are the same, guess what? The bases have to be the same. X equals 4. Okay. Example 6 and 7 on the back is all we have to get through in 3 minutes. Whoops. In all honesty, you don't need example 7 from me. Example 7 is using the LN button on your calculator. Okay?
What about the -5?
It's going to be undefined.
Undefined.
Okay, real quick though. LN is the natural log, right? LOG is logarithm, LN is natural log. The rules all work the same, everything's the same, other than a common log is base 10. What base is a natural log? And it is a base E. Okay, that is a base E. That's the big thing you have to know. The rules all work the same. When it says evaluate without using a calculator, rewrite this. This is natural log, which is going to be base E of E to what power? What's a square root as a power? 1/2. So look at that. Think about your rules. It's base E. The base on the inside is E. What do we know this is equal to? 1/2, because this is an E as well, right? What about B? Natural log of E to the 5th. What base is that? No, not 10. E. So we've got natural log of E raised E to the 5th. What's that going to be equal to? 5. Do you remember the equivalent rule on C earlier? E, natural log, what base is that? I can't write small enough. E, when those E's match, this is 4. Okay? Bell's going to ring. Example 7, you plug them into the calculator. Okay? You guys can handle that. It's 3.157, negative 0.734, and undefined again. I am not doing 8, and you will not have any examples like that in homework. 1 through 36. I know it's a lot, but it should go pretty fast.
Gosh, you just got Spanish and French.
Whoever got that,
I need you to sign this for me, please.